Big O notation is a mathematical notation that describes the limiting behavior of a function when the argument tends towards a particular value or infinity. In computer science, Big O notation is used to classify algorithms according to how their runtime or space requirements grow as the input size grows. Big O notation characterizes functions according to their growth rates. So, the different functions with the same growth rate may be represented using the same O notation. The letter O used because the growth rate of a function is also referred to as an order of a function. So O is the order of a function. Okay? Now, a description of a function in terms of Big O notation usually only provides an upper bound on the growth rate of a function. So, if we have a function, we have lower bound and upper bound. Also, if we have an algorithm, we have the lower bound and the upper bound, which we have take an example in the previous video that we have an algorithm that can be executed by 1 second and another algorithm that do the same result and the same computation in 10 seconds. So the lower bound is 1 second in this case, and the upper bound is 10 seconds in this case. So we are going to, and we are interested in understanding and studying this upper bound. We don't care about the lower bound. So in computers engineering, we don't care about the best case. We need the worst case to make it, to lower its order, to make it better and better. So the upper bound is denoted by O. So associated with Big O notation are several related notation using the symbol like O, omega, theta, and much more to describe other kinds of bound to asymptotic growth rate. Okay? So let's assume this notation gives the tight upper bound of a given function. Generally, it is represented as f of n equal to O of g of n. This means at larger values of n, the upper bound of f of n is g of n. We are not going to make a deep representation in mathematics, but I'm just telling you that this Big O notation is the highest order in the function. Okay, so if you have n to power 4 plus n to power 3 plus n to power 2, we took n to power 4 as its representing value. Don't worry, in the next videos, we are going to make an example about exercises about Big O notation, and we will clarify all of these things. I need from you to take a quick look about this lower bound, average time, and upper bound, and these algorithm time. So we start by O to of 1 and O log n. So this is the green O of 1. This is the greenish log n. This is the yellow O of n. So see guys, we are moving from the linear O n log n and n to n log n. You see the difference here, and we start by excellent. This is O of 1, excellent. Good, log n. Fair is O of n. These algorithms are good. While n log n is bad. And the horrible things that we may encounter is O of n to power n square, O of 2 to power n, and n factorial. Your mission, and you are asked to make the horrible notations and horrible algorithms like good and fair and maybe excellent algorithms. So your mission is to make these algorithms to these good algorithms. This is the data structure and algorithm target and goal. So this is your mission. You need to reduce the O notation, the order of the function of the algorithm to the least thing that you may you try to make it lower n. So we start from bigger n and we need to decrease it to lower